All right, fellas, lesson 106, effects of scaling on volume. I know, crazy. You're probably wondering why we're doing this again. This we have seen multiple times now. You guys should be rock solid on this by this point. But again, technically this is a review lesson from the book. So we are reviewing these three facts, right? The ratio of lengths between two objects is equal to the scale factor. The ratio of areas between two objects is equal to the scale factor squared. And the ratio of volumes between two objects is equal to the scale factor cubed. That's it. You guys know this. I know you know this. So we're just going to work through a couple examples here just to make sure we haven't forgotten it. All right. So here we go. First example. Tell me what the volume is, right? Again, this is more of kind of a proof as to why these work. So we're trying to find the volume of the larger cube. You can do that pretty easily by multiplying the area of the base times the height. But let's just take a look at kind of how this all ties into the first slide, all right? So first, let's find our scale factor, all right? So I know that my scale factor is equal to the ratio of sides or ratio of lengths. So we'll go bigger to smaller. So my ratio here is 3 to 1. And so my scale factor is 3, which makes sense, right? To get from 1 to 3, I have to multiply by 3, okay? So there your ratio of sides, all right? Okay, let's take a look at our ratio of areas. Well, the area here, right, if I'm just looking at the front face, right, is 1. 1 times 1. The area here is 9, okay? So my ratio of areas is equal to 9, we're going big to small, 9 to 1, which is equal to my scale factor squared. Let's look at the volumes. The volume of this cube is 1 times 1 times 1, which is 1. All right, my volume of this cube is 3 times 3 times 3, which is 27. So my ratio of volumes, sorry, I don't know why I jammed it in over here. My ratio of volumes is 27 to 1, which is equal to my scale factor cubed. All right. So again, just a little review. We'll get to the last example. This is the one you guys should be trying at home. Here we go. So I'm given a cube here. I don't know the side lengths, but I am told that the volume is 10. I'm given a cube here. I don't know any of the side lengths, but I want to know the volume. I am told that this cube, the sides are 2.5 times bigger, okay? So my scale factor is 2.5 here. Go ahead and tell me what the volume is. So go ahead and pause it. All right. So I know that if I have the scale factor, I can find the ratio of volumes. I take my scale factor and I am going to cube it since I am dealing with volume. So my scale factor 2.5 cubed is going to be 15.625. My ratio of volumes is equal to 15.625. Okay, so I already know that one of my volumes is 10. All right, so I need to say what over 10 is equal to 15.625 over 1. Or I could just take this and multiply it by 10, right? Which is going to be the same thing as what I do when I cross multiply. And so since I'm multiplying by 10, I'm just going to move it one place to the right. And so I get 156.25. And so that is my volume. That's it, folks. Again, this should be mostly a review for you, and I don't think any of you guys will have any trouble with this lesson. All right.